So welcome to DEEKSHA concept based digital learning. This is Neelima Devi, JL Physics, working at TSWRJC, North. We observe in our everyday life certain interesting things and wonder why it is happening. For example, a pen rubbed with a piece of cloth will pick up small pieces of paper. Why? In a thunderstorm, there are huge flashes of lightning. Why we observe this? When you run a comb against dry hair and bring it nearer to small pieces of paper, they will stick to the comb. Why this is happening? When you walk over a carpet and hold the doorknob, you receive a shock. Why? While removing a woolen sweater, we see sparks of electricity. Why this is happening? All these occurrences we observe can be explained through the study of electrostatics. So the learning objectives is, students, in this session you will learn about one of the fascinating branches of physics, that is electricity and magnetism. And what we learn in this branch, we also learn about the effects produced by charges at rest and in electrostatics. We understand the properties exhibited by the charges. We also know the methods by which we can charge an object. That is, first one is charging by friction, which is also known as triboelectricity. Second method is charging by induction, and third method is charging by conduction. With the help of mathematical expression given by Coulomb, that is Coulombs inverse square law, we visualize how the charge interacts with other charged bodies and how the charge is influenced by presence of electric fields. Now, the study of electricity and magnetism, it is basically the study of charges. In second year physics, we have 8 chapters on electricity and magnetism. The study of charges at rest, which produce only electric field, it is done in chapters electrostatic charges and fields and electrostatic potential and capacitors. And the study of charges in uniform motion or moving with constant speed produces both electric and magnetic fields. And this study is done in chapters current, electricity, moving charges and magnetism, magnetism and matter, and electromagnetic induction. Next one is AC currents. Now the study of charges moving with some acceleration which produce both electric and magnetic fields and also generate electromagnetic waves under certain conditions is done in electromagnetic waves. Now, next we talk about electrostatics. It is the study of charges at rest. Electro means charge, statics means at rest. These charges at rest produce electric field. These charges interact with other charges through the electric fields found by them. In our everyday life, frequently we encounter with electrostatic phenomena and electrostatic forces, whether we observe or not. Electrostatic forces are holding together the world of atoms with which every matter in this world made up of. Even human beings are made up of atoms. Now students, we learn about what is charge. Electric charge is the basic property of matter just as mass. Matter is made up of atoms and molecules. Atoms are made up of basic elementary particles such as electrons and protons. These elementary particles carry electric charge. And we all know, students, that electron carry negative charge and proton carries positive charge. And neutron is electrically neutral. The charge value on electron and proton is same, and it is 1.6 into 10 power minus 19 coulombs. If number of electrons and protons are equally present in an object, that object is said to be electrically neutral. If there are excess number of electrons, the object is said to be negatively charged body. If there is deficiency of electrons, the object is said to be positively charged. Now students, we come to our next topic, that is properties of charge. Charges are two types with different natures. By convention, we name one of it as positive charge and another one as negative charge. We know that all physical quantities are categorized into scalars and vectors. Now we treat charge as a scalar quantity because its nature and properties does not change with direction. So charge has only magnitude and a proper unit. So negative and positive charge indicate that they have opposite nature. So another property of the charge is additive in nature, that if we have number of charges, example, we have plus 0.5 coulombs and minus 0.3 coulombs and plus 0.2 coulombs. If you add them together, we have to follow the algebraic method of addition. Then the total charge will be plus 0.4 coulombs. So the next property of the charge is invariant. Invariant means it does not change with velocity. Charge value or property does not vary with velocity. Now students, the next one is the charge is quantized. Charge exists as integral multiples of fundamental charge. This fundamental charge is nothing but charge on the electron. The charge on the electron, students, already you know, that is minus 1.6 into 10 to the power of minus 19 coulombs. So this property tells that charge exists in discrete energy packets, not in continuous quantities. But in the research it is found that more basic particles called quarks carry fractional charges of minus 1 by 3 electron charge or plus 2 by 3 of electron charge. But it is believed that they never exist independently, hence they are not treated as fundamental charges. The property which I am going to tell is well known to you all, that is, like charges will repel and unlike charges will attract. That means a positive or negative charges repel, but a positive charge and negative charge attracts one and another. The next property of the charge is conserved. In an isolated system, the algebraic sum of positive and negative charges is always constant. In the given example, the rod is having a charge of plus 4 electrons, excess positive charge. Sphere is electrically neutral. When rod is touched, the sphere charge is redistributed, but total charge on rod and sphere system is same before and after the process. Now, it is time to understand the methods of charging an object. There are basically three methods. We learn one by one. The first one is triboelectric charging. Usually we say charging by friction. It is a process in which electrons will transfer from one object to another when those objects are rubbed against each other. Okay. Next one is, we have basic idea that matter is made up of atoms. So different objects are made up of different types of atoms. So physically and chemical properties of different objects will differ. So we are concerned about one property, that is electron affinity. The object with more electron affinity takes electrons from objects with less electron affinity. The object which takes electrons is having net negative charge and becomes negatively charged body. The object which loses the electrons is having net positive charge and becomes positively charged body. Now, in this way, one body loses the electron and another body gains the electron. If it gains the electron, it is called negatively charged. If it loses the electron, it is called positively charged. Now, during the triboelectric charging process, this electron affinity plays important role. When two objects rub together, example, we take rubber balloon and it is rubbed against animal fur. Atoms in both objects come closer. They come closer to such an extent that rubber balloon having more electron affinity, its nucleus attract electrons in animal fur. So rubber balloon takes the electrons and animal fur loses the electron. So this will continue as long as the friction between them is continued. Once we stop rubbing, the two objects become charged. Rubber balloon is as it gets excess electrons become negatively charged, and fur which loses electrons become positively charged body. Understood? One important point here we have to note that if we consider both objects as a system, that is fur and rubber balloon, then before charging both the objects are electrically neutral. That is, total number of positive and negative charges is 0. After charging also, the total number of charges of two body system is 0. Just one body gains the electrons from another one, so there is charge exchange between the bodies. Hence we can say that here law of conservation of charge is obeyed. Next, coming to the next method of charging, that is charging by conduction. In this process we bring a charged object in contact with a neutral object in order to charge it. Here we have one neutral object and one charged object. For example, we take a sphere as a neutral body in which net charge is 0. Now we bring a negatively charged body, that is rod, in contact with the sphere. So what we observe is that as there is excess negative charge on rod, it flows onto the sphere. Why this is happening means, this is because there will be a repulsive force between negative charges present on the rod, and they try to find a path to go as far as possible. So when a conducting body like sphere comes in contact, these negative charges moves away onto the sphere. So they spread on the sphere and rod. This flow of charges continues until their potentials are equal. In this process also charge is conserved. If we take rod and sphere as a one system, before conduction process net charge is charge on the rod. After conduction process also total charge on rod and sphere is same. So charging object, that is rod, loses some charge to the charged object, that is sphere. In this process charged object, that is sphere, acquired same charge as that of charging object, that is rod. So when we bring rod and sphere closer, there will be a repulsive force because rod and sphere have got same type of charge. We know that like charges will repel. So we can say that repulsive precedes conduction. This means before repelling each other, they undergone a process called charged by conduction. Now the third method of charging is charging by induction. In this method, we charge an object without bringing it in contact with other charged body. To understand this, we take an example in which we charge a neutral body with a positively charged body. That means there is a neutral body and a positively charged body. Bring a positively charged rod nearer to the neutral sphere. So neutral sphere means in it number of positive and number of negative charges are equal. That is net charge is 0. Now charge separation occurs in the sphere. The negative charges moves to the side nearer to rod due to attraction, and positive charges in the sphere onto the farther side due to repulsive force. Still the sphere is neutral. Only a happening thing is charge separation. That is net charge is 0 on the sphere. Now sphere is connected to the ground. We know that earth is a reservoir of charges. That is, whether charges moves into the earth or taken from the earth, its net charge does not change. Now what happens? Positive charge on sphere is neutralized as electrons flown from the earth, whereas negative charge on the sphere is held by positively charged rod. Now the sphere is disconnected with the ground and a charged rod is removed. On the sphere, we can see an excess of negative charge is present. That is, it becomes negatively charged body. This charge will now equally distributed on the surface of the sphere because of repulsive forces between them. We observe here that in charging by induction method, object gets opposite charge, as rod with positive charge induces negative charge on the sphere. Now, if we bring rod and sphere closer, we can see that there is an attractive force between them. So, we can say that attraction precedes induction. Here also, charge is conserved. If we take rod, sphere and earth as one system, then only charge is conserved. One more important point here is charge on the rod does not change while inducing the charge on the sphere. Now, our next topic is about how the charges interact with other charged objects. The interaction between charged objects is a non-contact force. That is, these forces act over some distance of separation, usually called action at a distance. This electric force between charges is either repulsive or attractive, depending upon whether the two charges are like charges or unlike charges. The strength of interaction between charges or strength of the force mainly depends on three factors. They are: first one is charge values, second one is separation between them, and the third one is medium in which the charges are placed. So these three factors affect the strength of the force. Now, the experimental observation shows that if you increase the charge on one object, it is observed that force between them is increased. Now, if we increase the charge on the other object, then also the force is further increased. That is, force is directly proportional to the value of two charges. If distance between the charges is modified, then also the strength of electrostatic force also modified in such a way that more the separation, less the electrostatic force. Less the separation, more the electrostatic force. That is, force and separation between the charges, they depends inversely on each other. Now, a scientist named Charles Augustin de Coulomb in the year 1785 gave an expression which provides an accurate description for electrostatic force between two objects. The condition is the objects act as point charges. If there are two charged conducting spheres, the charge is spread uniformly across the surface of the sphere. Then we consider the center of charges as center of the sphere. Now the sphere is considered as point charge and all excess charge we assume located at its center. So in Coulombs law, distance of separation means distance between the centers of two charges. Okay? The Coulombs law states that the force of attraction or repulsion, it is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Okay? In the formula, we have F means force between the two charges. Q1 and Q2 are the two charged bodies. Okay? F is proportional to Q1 and Q2 and F is inversely proportional to R square, distance square. If you combine these two, you can write F proportional to Q1 Q2 by R square. If you remove the proportionality constant, we get F is equal to K Q1 Q2 by R square. Here K is equal to 1 by 4 pi epsilon naught and its value is found to be 9 into 10 to the power of 9 Newton meter square per Coulomb square. Here we got one more physical quantity, that is epsilon naught. It means permittivity of free space. This epsilon naught indicates the dependence of the force on the property of the medium. The epsilon naught value, that is permittivity of the free space, is found to be 8.85 into 10 to the power of minus 11 Coulomb square per Newton meter square. This force always acts along the line joining the two charges. Hence, electrostatic force is called a central force. Okay, students, when charges are kept in a medium, then the Coulombs law is expressed as Fm is equal to 1 by 4 pi epsilon Q1 Q2 by R square. That means force is modified when the charges are kept in medium with the same separation, where Fm is the force between the charges in medium, epsilon indicates the permittivity of the medium. It indicates the nature of the medium. If we divide force between charges when kept in free space with the force when kept in medium, we get F by Fm is equal to epsilon by epsilon naught. This ratio is called epsilon R and also indicated with the letter K. So epsilon or K are called dielectric constant or relative permittivity or specific inductive capacity. Okay. Now F12 means the force acting on the second particle due to the first particle, and F21 means the force acting on the first particle due to second particle. When you observe, both the bodies or both the charges will apply equal and opposite forces on each other. Okay. The next one is, just now we learned that the force between two charges is equal and opposite. If the two charges Q1 and Q2 are positive or both are negative, in other words, if both are like charges, then force will be positive. So positive force indicates what? There is a repulsive force. If both charges are unlike, that is one positive and another one is negative, the force will be negative, which means that there is an attractive force. The force of attraction or repulsion, it is equal and opposite. Hence, they form an action-reaction pair. So this force obeys Newton's third law, that is, action is equal and opposite to the reaction. Now coming to the limitations of Coulombs law. That means when the Coulombs law is applicable, under what conditions this is applicable. So this law is applicable only for point charges and when charges are at rest. When the charges are moving, this Coulombs law does not obey. Now coming to the units of charge, the charge has units in SI system Coulomb. Okay, in CGS electrostatic system, the unit of charge we take it as stat coulomb. In CGS electromagnetic system, the unit of charge is ap coulomb. So how we define 1 coulomb? In the formula, if Q1 is equal to Q2 is equal to 1 coulomb and R is equal to 1 unit, if you put these values in the formula, we get F is equal to 9 into 10 to the power of 9 into 1 by 1 square. That means F is equal to 9 into 10 to the power of 9 newtons. So how we define this one? If two similar charges means Q1 is equal to Q2 is equal to 1 coulomb. So we can say that if two similar charges are separated by a unit distance, that means R is equal to 1 unit, then if the force existing between them is 9 into 10 to the power of 9 newtons, then those charges are said to be 1 coulomb. Understood, students? Now, from today's session, what we learned, what the knowledge we gained. Okay, we learned about what is electrostatics, that is, it is the study of effects produced by static charges. Some observations we make in our daily life. We learned about nature of charges and types of charges, as have learned about positive and negative, the properties of charges, and also we came to know 3 methods of charging objects, that is triboelectric charging, charging by conduction and charging by induction. Later, we have learned how the charges interact and a mathematical expression for it, which is explained by Coulomb. So, which is known as Coulomb's inverse square law. We also learned the units of charge in different system of units. And finally, we defined what is 1 coulomb. I hope students you learned about electricity, the introduction of the electricity. Now we came to the end of the session. From today's session, what we learned about? We learned about electrostatics. In electrostatics, we learned about the charges which are at rest, and it is the study of effects produced by static charges. That means how the static charges interact with other charged objects and how they form electric fields, and through electric fields they interact with other charged bodies. And also we made some observations in our daily life. You students, you do a assignment by observing certain situations connected to the electrostatics in your daily life. And we also learned about nature of charges, and we learned that there are two types of charges, positive charge and negative charge. The basic elementary particles such as electrons and protons carry same type of charge. That means, but one carries negative charge and the one carries positive charge. The charge value of electron and proton is 1.6 into 10 to the power of minus 9 coulombs. Okay, here positive and negative doesn't mean that they have directions. It indicates that they are of two different natures. Okay, the properties of charge, and also in that we learn the charge is quantized and the charge is invariant. And we also learned that charge is conserved. That means charge neither be created nor destroyed. Charge is always remains constant. Okay, and also we came to know that there are three methods of charging objects. One is called triboelectric charging. This is usually we call the charging by friction. The another method we learn charged by conduction, and the third method is charging by induction. Okay, later we have learned how the charges interact with other charges. For this, Coulomb did a mathematical expression for it, which is explained by the Coulomb. It is called Coulomb's inverse square law. Its statement is, when two charged objects are kept at a separation, then the electrostatic force existing between the two charges, it is directly proportional to the product of the charges. That means if the charge value increases, the force between them also increases, and the electrostatic force is inversely proportional to the square of the distance between the two charges. That means if the charge separation is more, the electrostatic force is less. If the charge separation is less, the electrostatic force is more. In the inverse, we have R square. That's why it is called inverse square law. So in today's session, we also learned the unit of charge. That is, in different systems, the charge has different units. In SI system, the unit of the charge is coulomb, and in CGS electrostatic system, the unit of charge is 1 stat coulomb, and in CGS magnetostatics, the unit of charge is 1 coulomb. And finally, we define what is 1 coulomb. 1 coulomb means if Q1 is equal to Q2 is equal to 1 coulomb. That means if two charges, similar charges we take, and you keep them a unit distance of separation, then if the force acting between them is 9 into 10 to the power of 9 newtons, then we can say that the charge value is 1 coulomb. Okay students, thank you very much.
Namah Shivaya.